All right, so today we're going to solve a system of linear equations. We're going to use the elimination method because I just have a simple way to do it. The only time we're going to do substitution is if we get an integer value for the first variable, we'll substitute to get the other. But almost everyone's going to come out fractions, so for the most part we're going to be using elimination every single time. But again, if you happen to get an integer answer, if you get x equals 2 or x equals -5 or something like that, you're going to substitute to find y. The two examples I have to show you today are going to come out fractional. So we'll take a look at how that works. So first thing, if you look at your procedure, the very first thing says make both equations x, y equals number order. Either they start off that way or they don't. If they do, fine. If they don't, fix it. So you can see here that this is x, this is y, this is number. The equal sign is not in the right position based on where x and y are. So I need x and y equal number order. So I'm going to move the 3y to the left to make that happen. 2x is not moving, it stays positive. 3y is moving, becomes negative. 21 is not moving, stays positive. The bottom equation, same deal. I want x, y equals number order. I've got 4x, I've got 3y, I've got 13. The equal sign's right here. I need to move the 13 over there to get the number on the opposite side of the x and the y. So 4x is not moving, stays positive. 3y is not moving, stays positive. And 13 moves, becomes negative. So create a system of equations so that x is first, y is second, equals, number is last. Line up the x's, line up the y's, line up the numbers. With elimination, our task is to get rid of a variable. So step 2 is to choose the variable I want to get rid of. And I usually choose after I look at the problem to see which one looks easiest to get rid of. In my opinion, it looks very easy to get rid of y, because what we're looking for in order to eliminate is opposite coefficients. Same number, opposite signs. This one's already set up like that, so we're good to go. Okay, I don't have to do any multiplication to make it fixed. It's ready to go in its current state. So once I establish in step 2, I'm going to get rid of y. I don't have to do step 3 because the opposite's already there. I move on to adding the two equations together. I'm going to add up the x's to get a new x. Positive 2x and positive 4x have the same sign, so I'm adding. 4 is bigger, so it's positive, so positive 6x. And notice I wrote positive 6x and I just write 6. X is part of the problem, make sure x is coming along for the ride. Negative 3y and positive 3y cancel, so it makes 0. Y has been eliminated from the problem. 21 minus 13, these signs are opposite, so I subtract. 21 is bigger, so it's positive. So 6x equals 8. Then we divide by 6. That leaves me with x equals, if I reduce the lowest terms, 4/3. And I do expect you to reduce fractions lowest terms. Look to see if both the top and bottom divide by the same number. If they do, please do. Now, in the next piece, step 5 says solve for remaining variable. It has an a and a b. If that answer, what we just found is an integer, such as 5 or -1 or 0 or anything like that, substitute. So if this said x equals 1, go right here or right here, change that to a 1, solve for y. If it's a fraction, though, we're going to eliminate the other variable. All right, so if you want to substitute the fraction, you're allowed to. But most of you have been struggling with fractions to some extent. You're not as good with fractions as you are with integers, so it's easier to eliminate to get the other variable gone. So my advice would be get rid of the other variable. So if I look at my original system of equations, which is right here, and I get rid of x instead of y. All right? So this is where I'm starting. I want to get rid of x. I want these to be opposite coefficients. I would need to multiply the top equation by -2 to make that happen. Oops. Okay. When I do -2 times 2x, that makes -4x. Okay, and again, algebra is all about what you want it to look like. You're allowed to make it look like that, but you have to have consequences for your actions. I want this to be -4x, go ahead. The consequence is that -2 is going to multiply by -3y, and -2 is going to multiply by 21. Everything's going to change, not just the one thing I want to change. So, if I do all that multiplication, I'm going to get -4x, which is what I wanted. -2 times positive 2x, opposite signs make a negative product. -2 times -3y makes positive 6y. -2 times positive 21 makes -42. so again, the blue is what I wanted to happen, the green is the consequence. Everything got doubled negative. Signs changed. Okay, so 2 times negative 2, negative 3 times negative 2, and 21 times negative 2. This has an x, this has a y. The bottom equation already is positive 4x, so positive 4x plus 3y equals negative 13. I'm not making any modifications to the bottom equation. I'm not liking my negative on the 42 there. It's too close to my equal sign. All right, so negative 4x plus 6y equals negative 42. The top equation modified. 4x plus 3y equals negative 13. The bottom equation exactly as is. And you can see now that my x's are opposites, just like the y's were opposite here. I could add them together to get rid of y. Now I can add these together to get rid of x. So, negative 4x plus 4x cancels, leaving us with nothing. 6y plus 3y, the signs are the same, so I add. I'm going to get positive 9y, positive because 6 is bigger. Negative 42 and negative 13 are the same sign, so I add, and 42 is bigger, so it's negative. All right. And then finally, if 9y is equal to 55, we divide both sides by 9 to get y is equal to negative 55 over 9. This does not reduce, as 3 does not divide into 55. 3 is the only prime number that divides into 9. So, once we have both x and y, we write our answer as an ordered pair. So we're going to write our answer in xy order. X goes first, y goes second. All right, there's the technique I'd like you to use to solve for these problems. Yes?
So how did you get negative 2?
This negative 2?
Yeah.
Okay. I make a decision of what this is based on what these things are. Right? I want them to look like this, one negative and one positive, the same number. So I'm asking myself, what can I multiply either one or both of these things by to make them into the same number, first of all?
You don't have to plug x back in for that.
Yeah, again, if x is a fraction, I prefer to eliminate the other variable.
Okay.
If x is a whole number or integer, I prefer to substitute back in. So the fact that we got x is 4/3, I could have said 2 times 4/3 minus 3y equals 21, but now I got to solve an equation with fractions in it. Again, you guys have been struggling with that a little bit. So to avoid that, I'm just saying let's get rid of x. 2 times 2 is 4, so that I can make them the same number with 2, but it needs to be negative. That's why I made negative 2.
Okay.
All right. Example 2, the second example here, this is like the last 4 problems. They're pretty much all 8 problems the same, but this one here, we already had these opposite. I think the first 4, you're already going to have one opposite. The last 4, you won't have that happening, so you have to modify things. But anyway, again, my task is, first thing, I want to make the problem the way I want it to be, which is something x, something y equals number. I want both equations to look like this. This one already does. This one doesn't. So if I had to modify anything, I'm going to just write them both down. So the top equation is fine the way it is. I got 1x plus 6y equals 7. The bottom equation, I got to move the 3x to the left to get what I want, which is x, y equals number, right? X in front. So notice 3x is positive, moves across, becomes negative 3x. 5y is already positive, so it stays plus 5y, and 3 is positive, stays positive 3. So each equation must look like this before you start trying to figure anything else out. Something x, something y equals some number. So this is x, this is y, this is the numbers. I want to either get rid of x or y, doesn't matter which one I choose to get rid of. If it were me, I would choose the x's. Numbers are smaller. Signs are already opposite. So again, I'm asking myself, what can I multiply by either one or both of these equations to make these the same number but opposite? The top equation being multiplied by 3 makes 3x, which is opposite of negative 3x, so that's the magic number. So I'm going to multiply the top equation by 3 to get the 3x I want. And the consequence of my action is I'm going to multiply 3 times 6 and 3 times 7. So the top equation gets modified into 3 times x, which is 3x. Positive 3 times positive 6y makes positive 18y. 3 times positive 7, positive 3, positive 7 make positive 21. In all cases, everything's positive, so all our products are positive. The bottom equation, I'm not modifying at all because it already has negative 3x, the opposite of positive 3x. So the bottom equation is fine the way it is. So now here's my problem. And now, if I look at my x column, I've created those those opposite things that I was looking for. So now I'm going to add the two equations together. Negative and positive 3x cancel, leaving us with nothing. 18y plus 5y is 23y. Same sign, add. 18 bigger, positive. 21 plus 3 is 24. Same signs, add. 21 is bigger, positive. 23y is equal to 24, so we divide both sides by 23. And that gives me y equals 24/23. Once again, that's not a friendly number to work with for substitution. So I'm not going to substitute. I'm going to go back and eliminate again. So if I go back to my original problem, the way it was structured here. So I got my x plus 6y equals 7. I've got my negative 3x plus 5y equals 3. Now I want to get rid of the y coefficient, or the y terms. So I'm looking at my y terms, these two guys. I want them to become the same number. What number can they become through multiplication?
30.
30, right? 30 is the number. 6 times 5 is 30, 5 times 6 is 30. We want to both become the same number through multiplication. It's up to us to establish what that number needs to be. And again, 30 is that number. In order to make 6 become 30, I need to multiply by 5. In order for, I don't know why I did red on that one. I need to multiply by 5. In order to make 5 become 30, I need to multiply by 6. Before I multiply, though, I need to make sure I'm going to get opposites, right? What's 5 times 6? Positive 30. What's 6 times 5? Positive 30. They're both positive. I want one of them to be negative. It doesn't matter which one. One of them has to be negative. So I just got to make one of those numbers, either the 5 or the 6, negative. I'm going to go with the 5. There's no difference. It's not easier to make one negative than the other. Just make sure one of them is negative so you get a negative 30y. So negative 5 times 6y makes the negative 30y I want. Positive 6 times positive 5y makes the positive 30y I want. The consequences are that I got to multiply this times negative 5, and this times negative 5, and this times positive 6, and this times positive 6. Again, you do what you want to do, but just to account for it by making sure everything gets changed the same way. So on top, negative 5 times x makes negative 5x. Different signs make an opposite. Negative 5 times positive 6y makes negative 30y. Different signs makes a negative. Negative 5 times positive 7 makes negative 35. Different signs makes a negative. On the bottom, positive 6 times negative 3x makes negative 18x. Different signs makes a negative. Positive 5y times positive 6 makes positive 30y. The same signs make a positive. And positive 6 times positive 3 makes positive 18. Same signs make a positive. Every time I'm multiplying, I'm focusing on signs. I'm applying a mathematical rule to establish the correct sign of my answer. I'm doing all this inside my brain so that all these rules are just commonplace, normal things for me. So we know exactly what the correct sign of every product is for the rest of our life, not just for the test that we took last year or the year before. All right? Once I get the 30y, negative 30y, this column here, which is opposites, that's what I was looking for, I'm going to add these together, add these together, add these together, in the algebraic sense of the word add. I mean, they're going to add or subtract based on signs. These signs match, so I add 23x. 18 is bigger, so it's negative. These are opposites, they cancel. These are opposite signs, so I subtract, and 35 is bigger, so it's negative. If negative 23x equals negative 17, we divide both sides by negative 23. Always divide by the exact number you're looking at, sign included. Negative 23 divided by negative 23. X equals, now 17/23 does not reduce, but 2 negatives makes it a positive. So positive 17/23 is the better answer. In our final step, once you know both x and y, is write an ordered pair in x-y order. So x goes in front, y goes in back. There's the solution. Again, you're finding two separate answers. We're not adding or subtracting or anything. So all we're doing is writing both answers down and putting a comma between them. That's the answer. So the fact they have a common, that happens more often than not. In fact, this one back here is a little weird. They didn't have a common denominator. So, I think even that was a 6, and usually they have a common denominator. The fact they didn't has to do with reductions,
Will
but
our worksheets have common denominators?
they might. Again, it's not a requirement to have common denominators in their answers. More often than not, they do.
Well,
So if every single problem you're doing, you're getting different denominators, you're probably doing something wrong. But if you're getting the same denominator most of the time, you're probably right.
will our homework have like whole numbers for the answers, or
I-
is it always gonna be fractions?
I don't remember. I'm gonna say maybe. How about that first? Non-committal as I can be. I don't remember. But they're allowed to. I'll check after I'm pass them out. I'll look at my answer key and see. I don't remember.